Hello students, welcome to CSDC and new academic year. This is one of the crucial year for you all students because this year you will be laying foundation stone for the higher education. Many of you might be interested or aspiring in becoming doctors or engineers. For 11th and 12th as well as in engineering and medical, the concepts of the topics of 10th standard would be helpful. Now before we start, I would first inform you that in 10th standard the important topics that we have to learn are mechanics, light, sound, heat, electricity and magnetism, and modern physics. The introductory part of these chapters you have studied in the 8th and 9th standard. I understand that due to pandemic condition, you might have not fully understood the concepts of these chapters. So I propose to revise these topics before I start 10th standard syllabus of relevant topic. Like today I am going to start mechanics, so I will revise important concept of mechanics that was studied in the 9th standard. I suggest that in future you should revise 8th and 9th relevant topic before you come to class to attend 10th standard physics class. Now, in mechanics is such an important topic that its continuation is in 11th standard and you will be learning in detail also in engineering college. As I told you, I will first revise the top portion of this topic which I learned in the 8th and 9th. You have studied about vectors and scalars. I hope you have remember this word. Vectors and scalars. Now, what are these vectors and scalars? What is the difference between them? Which are vectors? Which are scalars? I hope you remember. Vectors and scalars. This is the first topic of previous class that you should know. There are physical quantities whose complete description can be given only by magnitude. For example, temperature. If I say temperature of this room is 30 degrees Celsius, you are getting a complete information. But if I say that you hit this ball with a force of 4 units, you will ask me, in which direction should I hit? So the information that I gave you was incomplete, so you could not do the task. So for complete description, for force, you should know its direction as well as magnitude. So such quantities are called vectors. So force is a vector. You have studied in the previous class that displacement is a vector, but distance traveled is a scalar. Okay, suppose this is the initial position, this is the initial position, this is the final position. If a person goes from initial position to final position and returns back, and this distance is 3 kilometers, then if I ask anyone what is the distance traveled, you will say it is 6 kilometers. But if I say what is the displacement is 0, as initial and final positions are same location. So distance between initial and final is 0, so displacement is 0. So this is the difference between vector and scalar, how they have to be added. Vectors have to be added graphically or by taking direction into account, but scalars, direction is not important. It does not have a direction. Is it alright? Then we have also studied about rigid and non-rigid bodies. What is a rigid body and what is a non-rigid body? Now, if I give you iron ball, if you hit it with a bat or with any hammer, it will get displaced. It will move, but its shape will remain same. But if I give you a cotton ball, a ball made of cotton, and if I tell you to hit, it may get pressed and it may move also. So that is a non-rigid body. So in rigid body, we cannot change the distance between atom and molecules by a force. But in a non-rigid body, it can be, we can change the distance. So that means when the distance changes, the body changes its size and shape. If you take a pillow, you can change its size and shape by applying certain force. So, what is force now? Force means, so it is that physical quantity which will move a rigid body or stop a rigid body, or we say which will change its motion. If the body is stationary, it may move. If it is moving, it may stop. If it is moving, it may move faster. So, force is that physical quantity which changes the motion. And in case of non-rigid body, the force will move the body as well as it will change shape and size. So that I have written it here. You can read it. Okay. Now, then we have also studied about Newton's laws of motion. What are Newton's laws of motion? There are 3 laws of motion which tells us the relation between the various parameters of motion like initial velocity, final velocity, acceleration, time, and so on. So, second law of motion is very important, that we are going to use it in this chapter. What does second law of motion says? Second law of motion says rate of change of momentum. Now, what is rate in physics? In physics, rate means per unit time. You should learn this, very important. It will come in almost all the chapters. So, whenever the word rate comes, it means per unit time in physics. If you go to buy vegetable, so there rate will be per unit kg. If you go to buy milk, the rate will be per unit liter. So, in each, at different locations, the value of unit of rate is different. Is it alright? So now I will explain you Newton's 3 laws of motion. The first law of motion says that a body which is stationary would remain stationary, and a body which is in motion will continue to have its uniform motion until some force is applied to it. So that gives us the idea of what is force. So force changes the motion of the body. Then third law of motion tells us that to every action there is equal and opposite reaction. Now what do we mean action and reaction? If you take a ball, hit it on a wall, then the ball will bounce back. With what speed, with what velocity? If you hit the ball to the wall, it will bounce back perpendicular to the wall and with the same velocity with which it was struck. So, the reaction of the ball on the ball is same but in opposite direction. So this is very important that action and reaction are equal but opposite in direction. Very important point you should note is that action and reaction never acts on the same body. If they act on the same body, then you will say resultant is 0. But they are acting on a different body. If you are hitting a ball, the ball will hit you. So, action and reaction are on different bodies. This is very, very important point you should know. Now we will come and discuss Newton's second law of motion. Before that, you know, but I will just revise what is acceleration. What is acceleration? Acceleration means rate of change of velocity, v minus u upon t. V is final velocity, u is initial velocity, t is the time in which the velocity has changed from u to v. In physics, whenever we say rate, it means per second. So means what is the change in velocity per second. So that is acceleration. Now Newton's second law of motion says that force F. Newton's second law of motion says force F is equal to rate of change of momentum. What is momentum? M into V is final momentum minus M into U is initial momentum upon time in which it has changed. So if I take M common, I will get M V minus U upon T. Now what is V minus U upon T? It is acceleration. So force is equal to M into A. I have not got into details and shows you that proportionality constant is 1. So this is my force equation. This is very important. It will be used in physics quite often. Force is equal to mass into acceleration. So this is coming from Newton's second law of motion, that the rate of change of momentum is directly proportional to force and takes place in the direction of force. Is it alright? Now, you very well know that there are two systems of measurement. One is SI system international unit and one is SI system and other is CGS, centimeter gram second. Now let us try to define that what is unit force in SI system and what is unit force in CGS system. For that we will be using this force equation, F is equal to M into A. So if my mass is 1 kg, so what I am telling, if my mass is 1 kg, so if my mass is 1 kg, acceleration is 1 meter per second square. So force is equal to mass is 1 kg and acceleration is 1 meter per second square. Okay. kgf, so that 10 kgf is a force. Whereas if I say 10 kg, it is mass. I hope they have understood. I have explained to you everything written in this slide. Now we will proceed further. Now, in a rigid body, if we apply a force, we know that if the body is at rest and it is free to move, then when we apply the force, it will move in a straight line in the direction of force. There is a ball. Suppose this is a ball. It is free to move. So if you hit in this direction, it will move in this direction. To move in this direction. So in whichever direction the force will act, the body will move. Now, this motion of the ball, as it is moving in a straight line is called translational motion or linear motion, or you can say rectilinear motion. All means in a straight line. So when a force is applied to a body, to a rigid body, so that we are not taking into account into the energy spent in deforming the body. So when we are applying a force to a rigid body which is at rest, then the body will move in a straight line in direction of force. So this is called linear motion or rectilinear or translational motion. Okay. Now, the various ball initially was at zero velocity. So initial velocity is normally written by the letter u. So in this case, u is equal to 0. If I ask you what is its velocity after time 4 seconds, then t is 4, but I don't know the acceleration. So how I will get the acceleration? By using the force equation. Force is equal to mass into A. So if the force is 10 Newton, mass of the body is 4 kg, I will get the value of acceleration. So I will get the value of velocity after 4 seconds. Now somebody asks what is the displacement in 4 seconds? So then we will use this equation. And in case time is not required, then we can use even then displacement is known, then we use this third equation of motion. So these three are equations of motion which you have studied in 9th standard, but you should never forget this equation. It will be used quite often whenever we are doing mechanics or mainly it will be used when we are doing mechanics. Okay. So, knowing this, now we will proceed further. Suppose a body is pivoted as I have shown in this diagram. See, this is a ball, not ball. This is a round plate, and at this point it is pivoted. Pivoted means I have drilled a hole and fixed it to the wall with a nail. So at this point, this round body has been fixed with a nail. So this is called, it is pivoted at this point. Now if the ball, this is pivoted at this point, if I apply some force, it cannot move further. It will not move in a straight line, but it will rotate about this point. As I have shown, this is the force I am applying in this direction. So this body will move will rotate in this direction. So this is called that if a body is pivoted at a point, then if I apply a force, the body rotates about this fixed point, about the pivoted point. So this is called turning effect of force. Now, the magnitude of this turning effect of force depends on force, but it is not force. As I have shown in this figure, from this pivoted point I have drawn perpendicular to this force and the distance is d. So, the distance of the line of action of force from pivoted point is d, then we say moment of force is F into d. So, this is called moment of force. Remember, d has to be perpendicular to F. So, what will be the unit of moment of force? Force is in Newton, this is in meter, so it will be Newton meter. So, moment of force would be Newton meter, or in CGS it would be 9 centimeter. So, if you know the formula, you can write their units. So, this is the definition of moment of force. Moment of force is F into perpendicular distance of force from the pivoted point. So, even if force is less and d is more, moment of force will be more. So, moment of force depends on two parameters. Force and its distance from the pivoted point. Whenever we say distance, it means the perpendicular distance. Now, other word for moment of force is torque. So, normally we will be using this word torque quite often. So, what is torque? Torque is nothing but moment of force, or in plain words as I told you, this is nothing but turning effect of force. So, this is the turning effect of force. Is it alright? So there are three names: turning effect of force, moment of force, or torque, and it is given by F multiplied by D. Is it alright? So then we'll proceed further. This already I have told you. Now, in which direction does the body move? Now let us try to understand that in which direction the body will move. Rotate. So now I will give you real time examples where we are using concept of force. Simple example is door or window. They are hinged at one end. Always handle is fixed at the other end, so that the distance D between axis of rotation and where the force is applied is maximum. If the handle is fixed in the middle or at the end where the hinges are there, then you will have to apply large force because D would become small. So, handle is always fixed at the opposite end from the axis of rotation or where hinges are fixed. Similar is the case when we want to open a nut. In various machineries, things are joined by using nut. Now we want to open that nut. So, the handle of the spanner, if it is long, you will have to apply less force for opening the nut because M is equal to F into D. So if D is more, F would be less. Another example is of floor mill, where there are two wheels and in between you are keeping wheel for making floor. So the handle is at the extreme end of the radius, at the outer end of the radius, so that the force distance from the central axis is maximum and a person will have to apply less force to make the floor. Is it okay? Thank you.